In our next example, we have y squared over 2 minus y minus the fraction y over y squared minus 4. These denominators are not the same. And in fact, one thing hopefully you notice about this first denominator is that it's not written in descending order. That means that it's probably hiding a -1 factor. In fact, let's go ahead and write that in descending order and factor the -1. So this would be negative y plus 2, but when I factor the -1 at the same time, I'm going to have positive y, and then 2 divided by -1 is -2. So when I go to factor that denominator, write it in descending order and take out the -1. Minus, and then factoring the second denominator, keeping the first numerator as is, we get y plus 2 times y minus 2. Now when we're working with fractions, it's better not to have negatives in the denominator when we're adding and subtracting. It's ideal to actually move that negative out of the way. It's kind of in the way when we're trying to find a common denominator. And remember, with fractions, if you have a negative in the denominator, like 3 over -2, that's actually equivalent to having -3 over 2. There's no reason we can't just pop it up top. And that's what I'm going to do. So I'm going to make that negative go up top and be a negative y squared in the numerator. So my denominator then is just y minus 2. Well, when I go to find the LCD, I'm going to take that y minus 2 as part of it, and then I'm going to add in, or multiply in technically, what's left that is missing in the second denominator, which is y plus 2. And in fact, if you look at it, that second fraction had the common denominator already. So I'm going to multiply the first fraction by y plus 2 on top and bottom so that I get that common denominator. And then the second fraction is just going to stay as is because it already had the common denominator. Now that we have a common denominator, we can combine this into a single fraction. Y minus 2 and y plus 2 is the common denominator. And then I'm going to subtract the numerators. But remember, to subtract, I need to complete the multiplication that is in the first numerator. So negative y cubed minus 2y squared when I multiply that out, and then subtract the second numerator, which would just simply be minus y. At this point, there's no common terms, or like terms I should say, in the numerator. We've got a y cubed, a y squared, and a y term. We cannot add those together directly. We could try to factor that to see if we can get anything to cancel with the denominator at this point, so try to simplify. I can see that there's a y common. In fact, there's a negative that we can take out of all of the terms as well. So taking out a negative y, we're going to have y squared plus, watch your signs, y plus 1, because anything divided by itself is 1. Whenever you factor something common out of a trinomial, you should still have a trinomial in the parentheses. And then our denominator is y minus 2 times y plus 2. Now we can continue to factor, but you may recognize that it's not going to help us. Oh, I just saw a mistake. When we have negative 2y squared here, and I took out a negative y, I should have still had a negative 2 there. So I want to make sure that I have that 2 there. And when I go to look at simplifying this, I still can factor this trinomial. And I was kind of anticipating I should have a 2 there. So this does factor y plus 1 times y plus 1 over y minus 2 times y plus 2. So we were able to factor not only something common, but we were able to factor the trinomial that was left as well. But did it help us? No, because we do not have any common factors here. Y plus 1 in the top, y minus 2 in the bottom. Those are not the same. So it turns out, even though we did all this factoring in this stage and here, this answer 3 steps prior, or 2 steps prior, was actually just as simplified as the other two. The only difference is whether we have the numerator factored or not. So in my mind, you could give your answer in any of these 3 ways and it would be considered simplified. So again, when you're adding or subtracting rational expressions, you don't have to factor out the numerator if it's not going to help you to simplify. Because we didn't simplify, in fact, there are no domain restrictions to list. In our next example, we again have two denominators that have nothing in common. We also have a negative hanging out, but it's outside of the fraction this time. I do recommend throwing a negative into the numerator when you know there is one. So I'm going to write that as negative 3m. It just makes the process easier if you always put a negative if there's one lurking in the numerator when you're adding and subtracting. My first denominator won't factor. In fact, it is its own factorization right there, m plus 5. And then when I subtract and look at the second denominator, it will factor, that trinomial will factor to m plus 5, m minus 1. Once we have the denominators factored, we can find the LCD, grab the first denominator, which is m plus 5, and then look at the second denominator and add in any factors that are missing, m minus 1. So once again, in this particular fraction, or problem, the second fraction had the common denominator already. So we don't have to change the second fraction, we just have to change the first one. The first denominator was missing m minus 1 to have that common denominator. So I'm going to put the m minus 1 into the denominator, and if I do that, I have to multiply the numerator by it as well. So that adjusts the numerator. The second fraction doesn't change. My denominator stays the same, as does my numerator. Now we have a common denominator, so we can combine the numerators. So my common denominator is m plus 5 over m minus 1. And my numerators I can subtract, but remember to distribute before you collect like terms. So negative 3m squared plus negative 3m times a negative 1 is a positive 3m, and then minus 18m. Now this time there are some common or like terms to collect in the numerator. We've got only one m squared term, but we do have two m terms, minus 15m when we combine them, all over m plus 5 times m minus 1. That is my numerator simplified. At this point, we want to think about whether we can simplify the whole fraction. To do that, we try to factor the numerator. It may work, it may not. In the last problem it didn't, but let's see what happens here. I have a negative in common, as well as a 3 and an m in all of that numerator. So I'm going to take that out. When I do that, I'm going to get an m, positive m, and then a plus 5, because a negative divided by a negative is a positive. Now I can see that I do have a common m plus 5 that can be canceled in both numerator and denominator. So my final result is going to be negative 3m over m minus 1. And because I did cancel m plus 5, that means m cannot be negative 5. And I need to show that domain restriction to the reader, because you can't see it anymore because of the cancelization.